All right, we're going to use a graph to solve an equation in our first example. Here's our first equation. Solve negative 3x plus 20 equals 5 by graphing. Now, normally you guys would just be able to solve that equation, but we're keeping it simple for our first example so you can kind of understand what's happening. If you look down at part B, this would be trickier for us to solve just by regular solving. So we'll appreciate the graphing option on that one. All right, so when you're solving by graphing, what you're going to do is you're going to take each side of your equal sign and create a new equation with each of those, setting them equal to y. So we have y equals negative 3x plus, oh, and that's a 20. We're going to make that a 2, just so we have some numbers that will fit on our graph. And then on the other side of the equation, we have a 5. So we're going to write y, actually, I'm going to switch colors. Y equals 5. So we're going to graph both of these equations. Y equals negative 3x plus 2. So that is slope-intercept form. Our y-intercept is positive 2, so we can plot a point at positive 2. The slope is that negative 3, so we're going to go down 3, run to the right 1. Down 3 to the right 1, down 3 to the right 1, and we'll reverse and get those points going in the opposite direction. I'm not surprised this is lining up as a straight line because we had an x to the first power and we know that those are linear straight line functions. So there's our first y equals negative 3x plus 2. Our second equation is just y equals 5. We've talked about these where if it's just a number, y equals 5, it's going to be a horizontal line going through the y-axis at 5, which is right here. So I'm going to draw that horizontal line going through 5. Now what we're looking for is the point of intersection. I can see these two are intersecting right here. That ordered pair is negative 1, 5. And because we are solving an equation, our equation up here just had an x in it, remember? So our solution is actually just going to be the x value. So x equals negative 1. That is the x value where your two functions intersect. They share that x value, so x equals negative 1 is the solution to that equation. All right, so hopefully we kind of get the idea. You're going to graph two things, see where they intersect. Sometimes these might get a little bit trickier, the graphing. So it's just a good review. Our first equation is going to be the left side of our equal sign. So y equals the absolute value of x. I'm actually going to change this one. And then minus 2 on the end. This was just so we could get something that fits on our graph. The other equation we're going to write is the right side of your equal sign. So we have y equals 1/2 x plus 1. All right, when we graph this, y equals the absolute value of x minus 2. Remember, absolute value of x is a V-shaped graph. This minus 2 on the end tells us that we're going to translate our v just down 2 units from the origin. So it's at the origin, that's going to be the vertex of our v. This one has the pattern of up 1 over 1 in each direction. So we can go ahead and draw in each side of our v. All right, there's our first equation, y equals the absolute value of x minus 2. And again, maybe I should just say we change that. Our second one, y equals 1/2 x plus 1 is x to the first power. It's going to be a straight line. Your y-intercept is at a positive 1, and your slope is 1/2. So up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. And then I'm just going to backtrack. I'm going to draw in that straight line. And what we're looking for are points of intersection. Now, sometimes your graph will have 2 points of intersection, like this one. We're intersecting here, and we're intersecting up there. Now, because we said in our last part A example, our solutions are going to be the x values of those intersections. So what is the x value at that point right there? We can see it's a nice clear negative 2. And then what's the x value of our other point of intersection up here? If I just follow down to the x-axis, I can see that's going to be a 6. So we have two solutions, x equals -2 and x equals 6.